I mean, I would find it fun, but that's kind of why I'm here. All right, so now we kind of go back to scratch because we have to discover all the other types of trig functions using the limit definition. But now we have an idea that if I could just get the parent function, that I can tweak the derivative of the parent function based on whatever the coefficient is inside the expression. Right? So if this were secant 2x or secant 5x, it's going to be easier to handle. Now, that's not to say that it's always going to work out when you have something other than x in there, because if I have something like the secant of the natural log of x or something like that, composite functions, then all bets are off. That's a different story altogether. But for now, we do seem to have a rule that we can apply, at least in some situations. All right. Now, this one's a little bit more interesting because you got a few different approaches that you might consider taking. First thing I would recommend is a very subtle maneuver. Make the secant into 1 over cosine. All right. We're going to apply the limit definition again. It's still going to be one of those cases where we're best served by using the traditional one. So limit as h approaches 0 of 1 over cosine x plus h minus 1 over cosine x all over h. So it's definitely going to be more challenging right off the bat because I have to get a common denominator before I can even get started with my trig properties. All right, so let me do that. So top and bottom of this one by cosine x. Top and bottom of this one by cosine x plus h.
Why is it not just cosine?
Why is it? Say it again.
Never mind.
You good? All right, so I'm going to go a little bit smaller. Limit as h approaches 0. Now my numerator is just going to be cosine x minus cosine x plus h. The denominator is going to be a little funkier, but not too crazy. So cosine x minus cosine x plus h over cosine x times cosine x plus h. Now we have that h on the bottom that could be thought of as h over 1. If I keep change flip that, it's going to put it into this denominator as just an h. So save yourself a step and just chuck it in there immediately. All right. So at this point, you're kind of ready to get started on the expansion, going down this road to try to see if you can expand it for the purposes of cleaning it up, right? The only way it's going to happen, there are a couple of different ways it could happen, but the most useful approach would be to swap out the cosine x plus h for its equivalent identity. So this guy has to go. So limit h approaches 0, cosine of x minus parentheses, just to play it safe, cosine x, cosine h, minus sine x, sine h. All over the stuff on the bottom.
Are we gonna have to have all those trig rules memorized? Like cosine of x plus h?
more or less anyway. Because the not the short. What word am I looking for? The bailout is to store it into your calculator in a program. So, but you don't want to have to do that for every single possible formula that you could possibly do that that you could be expected to know. So, hopefully you know something.
But you said that's okay if we do that?
Yeah. That's why I went over it that one day just to show you how you can do it so that you don't get error messages all the time, So anyway, so I can distribute the negative. You could do it on the fly if you want. Just change signs here so that you don't have to rewrite the next step just for the purpose of changing a sign. Probably a good idea.
Sorry, it was bugged.
B?
Yeah, I just don't do bugs. I don't do bugs. I'm sorry.
I respect that. So I earned like a massive amount of street credit at my kid's elementary school because a bee stung me and I didn't react. What the kids didn't know is that I have like numbness down my extremities because of my spinal condition. So I didn't feel it. So all they saw was me get stung, not even react, just kind of look. The bee, like the stinger falls off and it dies, right? So the kids like go running away screaming at the top of their lungs. They're like, Mr. Cat is so tough. The bee stung him and died. And, he killed the bee just by it was great. I didn't feel it, so it was a win-win for everyone except for the bee. The bee's dead. So I'm, for some reason, going crazy with parentheses. I don't know why. I couldn't stop myself. Yeah, it just is what it is, I guess, as Mr. McCallie would say. Or as Mr. Shippey would say, yep. Or, hey man. That's a good Shippey.
Hey, can I borrow some textbooks? It's like,
So he's like the epitome of chill.
I have library duty because kids could literally be like yelling at each other across, and he just is like reading his newspaper.
Yeah, which is the opposite of me in library duty, which many of you have experienced. I'm like, I'm just trying to grade these papers. Can you just stop? Just stop, yeah, please. I only start losing my mind in there when I've had to reread the same problem like 14 times because of the distractions. That's just a me thing, I guess, but I guess I complained enough, so now I got freshman study hall, which is like infinitely worse. They're like, oh, you don't like library duty, huh? Oh, okay. Like, thanks a lot. I think the freshman study hall issue revolves around the fact that they don't understand how to play the long game. Like, I'm going to be here for a long time. I've been here for a long time. I'm going to be here for a long time. And so it doesn't occur to them that our paths are going to cross again at some point. So when they're being like not the nicest people in the world to me, it does not occur to them that like 3 or 4 years later, they could be sitting where you're sitting. Like with me as a teacher, they will have forgotten that moment. I will not have. So, that's how it is. So we get to this step here, and it's a god-awful mess. I'm sorry, I can't see God in the classroom. But believe it or not, it's pretty much done. The problem is solved. It just looks like a terrible disaster, but it's a beautifully terrible disaster. Because tucked in there is this, right? Okay, you're not impressed. Got it. Yeah, I'll accept that. Yeah, a nice whoa. Something of that ilk.
Oh, and then the sign H and the H.
There it is.
Wow.
Oh, wow. I'll take a wow, too. I like wows. So those will cancel out also. All right. Now, you might have canceled out the cosines here, too. That's a good move, but ultimately irrelevant, because this is going to 0, so everything here is going away. So canceling out the cosines is like a good observation, but it doesn't really do anything. What we do have here on this one is the sine of x over the cosine x times cosine x plus h. All part of the limit as h approaches 0. All right, so I almost fell. I haven't fallen yet. It really is really just a matter of time. I'm due to go down at some point. And it's not like dropping a feather. It should be like a ton of bricks. And so, I don't know, it's not going to be pretty. So anyway, when I replace the h with a 0, I get 2 cosines on the bottom multiplied by each other. So I could actually multiply them by each other, but I'm actually not going to. I'm just going to leave it, at least for the moment, as cosine times cosine. You might be tempted to write it as cosine squared, but a simpler form would look like this. I can take the sine over cosine and make that into what? Tangent. I can take the cosine that's on the bottom here and make that what? Secant. All right. And this actually is the derivative, or the more popular way of writing the derivative. It's just for some reason they like to put the secant first. So we say secant times tangent. So that would be the derivative with respect to x of my secant function. So that's a pretty significant departure from, look at that mess, it's great. I fit it perfectly. Yeah, it's a significant departure from what we had, because sine was cosine, cosine was negative sine. Secant is somehow secant tangent. It's kind of like defining the word, using the word in its own definition.
So like in the brackets, there's like still an H, and then when we drop down, there's like not an H anymore. Where does it go? Oh, we apply the limit. Okay.
Exactly.
If on a test you wrote tangent x times secant x, would you get cosine?
Not at all. Yeah, perfectly fine. And in fact, on a test, if you wrote it as sine over cosine squared, that's fine too. I just wanted us to get to what every textbook calls the derivative of secant, whether we like it or not, you know. So we have other problems here, like tangent, cotangent, and cosecant. Now, we learned something yesterday that allows us to get the answer for the derivative of cosecant immediately without doing any of this. All right. So let's go back what I have on the board. So we know that the derivative of sine is cosine, and we know that the derivative of cosine is negative sine. All right. So the relationship between these two is what? What are they? Relative to one another? There's a special word for it. Having to do with that.
Complement.
That's the root of it. Yeah, they're complements of one another. We call those co-functions. All right, but the co stands for complement, so you're right. That's actually a better answer than I was looking for, so it's really good. Yeah, because complementary angles are angles that add up to 90 degrees, right? But in the context of the graph, they represent 90-degree translations, so horizontal movements. If you shift a sine wave 90 degrees, you get a cosine wave. If you shift a cosine wave 90 degrees, you get a sine wave. So that's why they're complements and therefore co-functions. All right? So these are co-functions of one another. What's the relationship between these two? Well, the derivatives themselves are, the co part is still going to apply. They're co-functions directly, or was some kind of an adjustment made? Oh, because this was a positive sine to a positive cosine, right? And with the signs were inverted, so we would say negative or opposite, negative co-functions. All right, so if I know, for example, that the derivative of secant is equal to secant times tangent, I can figure out the derivative of its co-function, cosecant, by applying that relationship. So first, it was positive, so make it negative, and find the co-functions of each of these. I love when people pack up right at the moment where I give you a piece of information that would make your life easier. It's cool, you don't have to write it down or anything. You don't have to get it right on the test. So tomorrow we'll have plenty of opportunities to practice with this because you do need time, definitely time to play around with this stuff.